Hi everyone. Today we are going to discuss about the title on permeability of soil. Here permeability play a vital role in the design of foundation, earth dams, highways, drainage system and ground water flow problems. Okay. Here these are the contents we will discuss in the upcoming portion. The first one is a permeability of soil, and then how the permeability of soil is measured, and then soil permeability testing equipments, and main objectives of permeability of soil, and characteristic of soil permeability, and then importance of permeability of soil, followed by Tarsis law of permeability of soil, coefficient of permeability of soil, and finally concluded with determination of coefficient of permeability of soil. First start one by one. First one is the permeability of soil. Here permeability refer to the ability of soil to allow the water to passes through its voids. In civil engineering we are mainly concerned with water flow through soil. This property governs seepage, consolidation, settlement and stability of soil structure. According to Tershaki, permeability controls the rate of drainage and dissipation of poor water pressure, which directly affect the stability of soil structures. The next one is how the permeability of soil measured. Okay, here permeability of soil measured using the method such as constant head permeometer or falling head permeometer, pressure plate apparatus, double ring infiltrometer and laboratory parameters. These methods involve measuring the flow rate of water through a soil sample under controlled condition to determine its permeability. Okay, and then the specific method chosen depend on factors such as soil type or research objective or available equipments. Okay, the next one is a soil permeability testing equipment. Here permeometer or laboratory device used to measure permeability under the controlled condition. Infiltrometer are used to measure surface soil permeability in the field. Pressure plate apparatus is used for unsaturated soil. Okay, and then in the data acquisition system, in the advanced laboratory testing, data acquisition system are frequently employed to automate measurement and ensure accurate data recording. This system typically encompass a state-of-the-art sensor, transistor and software for monitoring and analyzing the flow rate during the permeability testing. After that, the objectives of permeability of soil. Here various objectives are involved to analyze the objectives of permeability. Here main objectives are to estimate the groundwater flow rate, or to analyze the seepage in dam, and to evaluate the foundation drainage, to predict the settlement rate, or to design the filter and drain, or to estimate the yield of aquifer and to determine the seepage problem in dams. Okay, here all the things are very important of objectives of permeability of soil. Here this one is a characteristics of soil affecting soil permeability. Here soil structure play a major role in permeability. Well graded soil have larger porous space and higher permeability, and compaction reduce the permeability by decreasing the void spaces. The fully saturated soils allow the continuous flow path, resulting in higher permeability. According to the Lambie or Whitman theorem, permeability decreases exponentially with reduction in void ratio, especially in the fine grained soil. Okay. Next topic is importance of permeability of soil. Here, permeability affects the consolidation and pore pressure dissipation. Low permeability soil consolidate slowly, leading to the delayed settlement. In highways, poor drainage due to low permeability weaken the subgrade. Okay, here next one is a Tarsi law. This law is very important. Is used to determine the permeability of soil. Here the Tarsi formula is Q is equal to KIA or V is equal to KI. Here Q is equal to discharge, A is equal to cross section area of the soil corresponding to the flow, and then K is a coefficient of permeability. After that I is the hydraulic gradient, and L is equal to length, V is equal to velocity of flow or discharge velocity. Okay, these are all the very important things to used for Tarsi's law to analyze the permeability of soil. After that, coefficient of permeability of soil. Here, coefficient of permeability is defined as a velocity of flow under unit hydraulic gradient, and also it is expressed as a meter per second. And sand have high permeability while clay have very low permeability. Okay, here three columns are there: types of soil, one column; coefficient of permeability, another column; drainage characteristic is another column. Here gravel is a pervious drainage characteristics, and sand have is a pervious characteristic; silt is slightly pervious, and clay is a impervious characteristics. And also values of gravel is greater than 1 centimeter per second, and sand is a 1 to 10 power minus 3 centimeter per second. Silt have no coefficient of permeability value, and less than 10 power minus 6 having clay coefficient of permeability value. Here determination of coefficient of permeability of soil. Constant head permeability test we have used, and falling head we have used. Okay, first one is a constant head. Here constant head is a test is suitable for coarse grained soil. Water head is kept constant here, and discharge is measured over the time. Here top portion is a inlet, bottom portion is a outlet. Here manometer is sidely portion is fixed, and then constant head water reservoir here applied. Okay, and also permeable disc bottom of a portion we have used to determine the constant head. Here this formula is used to determine the coefficient of permeability of soil in the constant head method. K is equal to QL divided by AH. Okay, equal to QL divided by AHT. Here K is a coefficient of permeability of soil, Q is equal to discharge, and capital Q is a total volume of water to carry, and T is a time period, H is equal to head causing flow, which will be constant, hence the name of the method. Okay, and L is the length of the specimen, and A is equal to cross sectional area of the specimen. The second one is a falling head method. Falling head method is a test is used for fine grained soil. The water head decreases with the time, and the permeability is calculated using the logarithmic calculation. Here we use measure H1 and H2 value. Okay, after that we get the falling head reading. This formula is used for falling head method. K is equal to 2.303 AL divided by AT logarithmic 10 of H1 by H2. Here K is a coefficient of permeability measured in meter per second. A is a inside area of the standy pipe. A is equal to pi by 4 d square, and d is equal to inside diameter of the standy pipe, and L is equal to length of the sample. A is a inside area of the specimen. A is equal to pi by 4 d square, and capital D is the inside diameter of the perimeter. Here T is equal to the elapsed time of the test is measured in second. H1 is equal to elevation of water in the standy pipe at a time of T is equal to 0, and then H2 is equal to the elevation of water in the standy pipe at the time equal to T. Okay, Here this one is different, field test. Here also called as pumping out test. Here pumping out tests are conducted for large soil masses. Water is pumped from a well and water level in observation well are measured. However, this test very costly and can be justified only for large project only. Water is pumped out from the main well at constant rate until the water level in the observation well becomes steady or constant. This flow quantity and the level in the observation well are noted. One of the two basic flow condition will apply, namely unconfined flow. Another one is a confined flow. Here, before getting into the detail of pumping out test, it is important to know about the aquifer. Here aquifer is permeable formation that allow a significant quantity of water to move through its under field condition. Okay, this one important, and also note it. Broadly, there are two type of aquifer based on position of water strata within the soil, namely unconfined aquifer and confined aquifer. Here this figure shows confined aquifer and unconfined aquifer for your reference. Here confined aquifer contains impervious stratum. In the unconfined aquifer not contained impervious stratum. Okay, here the drawdown curve will vary, okay, compared to confined aquifer. Unconfined aquifer water level here noted in the below the ground level. Okay, this is for your reference. Okay, to conclude, the permeability is a key soil property that control seepage, consolidation and drainage behavior. Okay, understanding the permeability help engineers design the safe and durable structure. I hope this session has helped you understand the concept clearly. Thank you. Thank you all. Thank you for watching.